Hello, this is Mike Lively, and this is Professional Paper Vision. And today we're looking at using CS4. So previously we had created an animation engine using 18 lines of code, and now we're going to use CS4, the Flash 10 engine, to create an animation engine using only 13 lines of code. Now, a reduction of 5 may not seem like a whole lot as far as lines of code are concerned, but what we're going to show you is significant. An alternative title to this section might be Native Z. We're going to show you how powerful the Native Z is. So we're actually going to show you two examples. We're going to show you one basic of a spiral that we created in one of our Flash tutorial sessions, and we're going to show you the animation engine that we created in the last tutorial. So let's go to the spiral first. So we did an entire Flash CS4 tutorial to go along with this section of the book. So if you're not familiar with Flash, you can go through this tutorial set. It's about 12 videos, and I'll bring you up to speed and give you the knowledge you need to do well in this chapter 1. And in one of the videos that presented in that tutorial section, we did looping, and in the looping section we actually created a spiral. So we're going to open up that program, and I'm going to show you how it works and then how to convert it using Native Z. Let's do that right now. So we're in Flash right now, and what you're going to want to do is go back to the Flash CS4 course that comes on the book's website or on the book's blog, and look at the looping video. That'll bring you up to speed of where we are right now. And what we've created here using the scaling equation is basically a spiral. Let's go and run it real quick. And there's my spiral. Beautiful. I love it. It's very attractive. And now we're going to show you how to do this using the Native Z. So let's just review real quick here. Right here you have the scaling equation. As we learned in the previous section, basically we're going to create a scale. That's Thales' theorem. It's just basically a focal length divided by focal length plus z. And you're going to multiply that times sine and cosine to get a scale, and then you're going to do a scale on the ball, x and y. And so that's all explained in the looping video. Go back and see that. But what we're going to do now is we're basically going to eliminate all this code right here. And we're going to do that by using the Native Z that's in Flash 10. So let's go and take a look at that code real quick. So in Flash 10 you now have a Native Z component, so you no longer need a scaling equation. It's done for you automatically. You're not going to need to adjust your ball by scale, so we're going to take these equations and lines away. Let's get rid of the scaling. And now let's add two new equations. Basic x and y will basically be based upon sine and cosine, spinning around and around in a circle. And you no longer need to scale the ball because that's done automatically. That's all Native Z. And so all you need to do now is adjust the ball's Z value. And so you've replaced basically 1, 2, 3, 4, 5 lines of code with 3 lines of code, and it's going to run beautifully. Let's just get rid of that. There's your new code, and all thanks to Native Z. And let's run it and see what happens. There you go. And doesn't that look beautiful? It really does. And it actually looks better. It looks more symmetric than the one we looked at previously. So that's the power of Native Z. Now let's apply that to our animation engine. So we're back in Flash, and this is our animation engine built with 18 lines of code. Let me run it and remind you of it real quick. And we just have a ball spiraling in and out of the Z direction. Now, able to do this, however, we have to do some perspective scaling. And specifically, there are these 1, 2, 3, 4, 5, 6 lines of code that we need to do that with. Now go ahead and review the video previously, and we'll show you how these work. But basically it's just perspective scaling once again. Here's a perspective scale. Here's the scale of the sine and cosine. And here's the scale of the ball. And we can actually get rid of all of those and just add 3 lines of code in its place because we no longer need this creation of Z through perspective scaling. That is all now native. That's right, to the Flash engine. So let's get rid of these lines of code. I'm going to paste in just 3 lines of code to actually take care of this. There we go. Actually get rid of that. And what I've done here now, basically, once again, sine and cosine, but no longer have to scale it. And I have a ball Z, basically, that I just assign an angle to. So basically, all this is handled internally now. As Z changes, X and Y are adjusted all automatically. So let's run this and see if it works. And there's our ball, going in and out of the screen. And here it comes back. So isn't that cool? All now handled using the Native Z component. Let's count the number of lines of code. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. I lied. I said 13 lines of code. What happened? Well, guess what? I no longer need this Z position, do I? And I no longer need a focal length, do I? So now let's count it. That's right, 1 through 13. Hey, I'm not a liar. And let's run that one more time. I'm so glad. Got an error. Let's fix our error, of course. Let's see what that is. I accidentally just cut off my angle. Let's go ahead. Got so excited. Let's run it now. And there you go. So that's great. But you notice the perspective has changed a little bit. Actually, the vanishing point has shifted a little bit. We're going to talk a little bit about vanishing point next time. Okay, this was Michael. I hope you enjoyed the video. I sure did.